Here we go. A relation. Relation, vocabulary word number 1 of Unit 2, is a set of ordered pairs. A relation is a set of ordered pairs that represent a situation. Now, for right now, our relation that they give us that we're going to be working with is just like a set of numbers. But later on, as we go through this unit, like the relation will be a set of ordered pairs that represent a number. So like it could be the number of people on a bus after X number of stops, right? Like it's going to be a comparison, values that go together. Right? They're numbers that have a relationship to each other. Okay? Typically, I'm not great at making them. They're grouped by brackets. Those little squiggly parentheses. You do not have to be able to make beautiful ones. You can put a squiggle on the front and a squiggle on the back, and that works. So, again, it's going to be the set of ordered pairs. And it's going to be like, hey, this relation, this set of ordered pairs belongs together. Okay? That's just the term that they belong together. They represent something. For example, one 5, 2 3, 4 2, 3 2. This would be a set of ordered pairs that belong together. They represent something together. It may be the number of siblings you have and how many pairs of shoes. Does it have a relationship? Probably not, but they belong together in this comparison. It could be the number of elective classes you have and the homework assignments that you have tonight. Right? Like it's a relationship. They belong together. It's two pieces of data collected, right? Doesn't mean that they're always increasing or always decreasing or that there is a correlation. But it's just showing that those data sets represent something. There are ordered pairs, equation, 4 ways of representing. We can represent it as ordered pairs. Done. We can represent them in a table of values. X, comma, Y, and then I make a table. 1 5 2 3 3 2 4 2. In this table of values, what's different from my table of values to my set of ordered pairs? I have 4 2 here. But what did I do? Ruby, what did I put? What did I do? I put my X's in order. Right? My X values are in order. When you make the table version of it, your X values are in order. Now, sometimes your X value repeats. Sometimes you have 2 of the same X value. You can pick which one goes first there. But your X values go in order. I can have a table of values. I guess let's label this I can have ordered pairs, right? I can have a table of values. I can have a graph. I'm going to make this graph real ugly. Doesn't have to be beautiful. 1, 5, 2, 3, 4, 2, 3, 2. It does not have to be this beautiful graph. Some of you are spending way too much time getting rulers out and making things precise. I mean, it's not a terrible graph. I said it was going to be real ugly. It's not that ugly. It could be worse. Right? But like, I can work with this. Do not spend your time like putting in all of the tick. I don't even use this quadrant. Why am I bothering with it? I'm not even using this quadrant. Don't give me 10 tick marks when the largest number we're using is 5. Right? Don't spend a lot of time making things crazy when you're looking for practice of a skill. So there's a graph. I can put it as ordered pairs. I'll give this a box too so that you can see it. And then the last one you may be familiar with from IM7. Is a mapping diagram. A mapping diagram is where I take my X values in order, my Y values in order, and I connect with lines. Mapping diagram. A mapping diagram is great. Like, it is a really easy way to look to see if relations are functions, which we're about to talk about. Mapping diagrams are great. They do look a little busy. So for example, I would do 1, 2, 3, 4. Put it in a box. And then for my Y values, I would do 2, 3, 5. Because the 2 repeats, I only list it once. Don't repeat numbers in the same column. Now I would say 1 goes with 5. 2 goes with 3. 3 goes to 2. And 4 also goes to 2. Does that make sense? It's just my list of numbers here, my list of Y values here, and then I connect my X value to its Y value. I draw a line from the X to the Y, from the X to the Y. And if 2 things share a number, it just gets 2 lines drawn to it. Mapping diagram. Okay. Here's the rest of our vocabulary. We talked about relation. I'll highlight it as a vocabulary word. Now, we're going to move to domain. When I talk about a relation, I will say the X values, correct? Like I might say, hey, what are the X values of this relation? I can also say, what is the domain? Domain is our vocabulary term for X values It's the independent variable. In. Domain is what goes into the problem. It's the x. Right? When I have an equation, x is my horizontal axis. This is my independent variable. I put in $5, I get out blank cookies. In is my independent variable.
Are you needing to be recording?
Yeah, it doesn't turn off on me when I do that. But thank you. Next vocabulary term is range. Range is the y values. If I put in $5 to the vending machine, depending on what I choose is what comes out, correct? But I can't change how much money I put in. I have a $5 bill, I put in a $5 bill. But what I choose to come out is my dependent variable. What I get depends on what I pick. Dependent variable. How many layers of clothing I wear depends on the temperature outside, right? So my independent variable is the temperature, because I cannot control the temperature outside no matter how hard I try. What I can control is the number of layers of clothing I put on. That's my dependent variable. Does that make sense? I think it helps to say the sentence. Like to say, the temperature outside depends on how many layers of clothing I have on? No. How many layers of clothing I have on depends on how hot it is outside. Today, you'll be looking at these equations and you will be determining from their domain and from their range, are they a function? Is this relation, set of ordered pairs that belongs together, a function? And a function is a relation where all domains are different. A function is where all domains are different. What are domains? X values. Every X value is different. If you have the same X value, it's not a function. It's technically where each independent variable results in one dependent variable. Right? But it's all domains are different. I can put a little hint here. No X value repeats. No X value repeats. We will glue this in a minute. I don't like to glue and then write on stuff. So let's write on it first and then we can glue. This should feel familiar from last year. Vertical line test. Okay. All right. My picture is kind of hard to see. That one's okay. That one's okay to see. I think it's really just those two that are hard to see. All right. Vertical line test. It says on our paper how to perform the vertical line test. Bullet number 1 says, when a relation or a set of ordered pairs are table, it is easy to determine if it is a function by looking at the x values. If I have numbers, it's really easy for me to tell, right? I look for a repeating number. I'm like, duh, the number 2 happens twice. It's not a function. This is kind of a pain. Do you want to write down all of those ordered pairs? Absolutely not. That sounds terrible. So instead, what we use is the vertical line test. What does vertical mean? Like if you're explaining it to a kindergartner, what does it mean? Up and down, right?
Go down.
So, a function we'll just go it. Never mind. Is the vertical line test. You take your pen, you take your pencil, you take a SOAR ticket, you take something that is vertical, up and down. And you go across your picture vertically. Does this make sense?
Yeah.
You drag it across vertically. It is a function if no x value repeats. Does that make sense? I don't love that the definition uses a negative term in it. So maybe you could say all x values are different. But it's really nothing repeats. So you cannot have a dot above a dot. There is no dot above a dot. Nothing is vertical. It passes the vertical line test. If it's not a function, x value repeats. It has a dot above a dot. If there's a dot above a dot, boop, not a function. I also have students, it gets a little messy, but I have students who like draw a vertical line and they're like, that's okay, there's only one dot there. I'm gonna zoom in real close. Try not to barf. But then I get right here and look, there's a dot here and a dot here. There's a dot above a dot. This is not a function because the x value repeats. There are 2 ordered pairs that have the same x value. This would be -2, +1, and -2, 0. It also fails it right here and right here and right. It fails a lot. In this one, no, that's good. That's good. That's good. 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 Did anything have 2 dots on the same vertical line? No. So this is a function. Here, function or not a function? Because right here, I have a dot here and a dot here. Not a function. Oh, it was trying so hard. Here, ooh, function or not a function? Because right here, there's a dot and a dot, not a function. Sometimes they're hard to see. How about here? Function. Nothing repeats. No x value repeats. Y values repeat, but that doesn't matter. Only x values. How about here?
That's double, not passive.
Function. Sometimes it's hard to tell. Like a parabola, that's what this is called, exponentially gets narrow, like stops going up at such a large rate, but it's still always moving out a little bit. How about this one? Nope, multiple failures, right? This one? Function.
There has to be.
This guy? Nope, multiple failures. Okay, one last thing that I'm going to draw a picture of real quick right here. You may encounter something that looks like this. Oh, sorry. What do you think about that?